Hello, Professor. So this is our progress report for this week. So basically, we actually found a way to benchmark our entire project with a software sniffing tool called Snort. As we explained the final presentation, we gathered results for the throughput for this particular algorithm, the using NIDPS package provided by Snort, a hyperscan fast pattern matcher, which is a software based tool, is emulated in hardware by us, and we are using this particular software tool to benchmark our results. So using these results, so you can see that we have a pretty good amount of increase in the performance using the software from compared to the software solution. So we are hoping that we can achieve better results going forward if we are able to find anything new. Now, Bia will explain the context research, which you had questioned us regarding the context of using our solution in IoT. Uh, so, Bia, can you take over?
Yeah, so we took a look at IoT security, and we looked at how other people and other research teams are tackling the problem. We found a couple papers that did a good comparison listing what kind of system that they target, what kind of mechanism that they use, is it signature or anomaly based, and the way they simulated their methods, what kind of attack that it targets, and the pros of their search of their method and the cons of their methods. And we found out that according to the survey papers, it seems like that most of the people are doing their IoT security solutions by authentication and some encryption, some trust evaluation, and only one that was doing IDS. And according to the paper, most of these methods they face a couple of challenges listed here. So I did a comparison between those challenges and versus how our approach stand up to these challenges. And we see that for most of them, our solution can be tweaked to tackle these challenges, or that in itself works very well at countering those types of attacks. So I think our projects still have a really good value for the IoT security context. And now Manoj is going to show if our approach is practical by looking at the power and area estimation of our hardware design to see if it's practical to port our solution to IoTs.
Yeah, a lot of the papers that we looked for this background research tend to mention low power and CPU utilization as benchmarks for IoT-based routers. So to make sure that we compare them properly, we are trying to get an estimate of power consumption and the area of our design itself. For that, we are going to use Xilinx ISE's XPower tool, as well as an open source tool called OpenRoad. Yeah, so OpenRoad is actually an open source tool that we have available that takes in a Verilog and then just gives out area estimate of that on a particular node that we want to manufacture it at. And it also gives out a maximum achievable frequency at which we can run our design. So we are hoping to have, I'm actually looking into these and how to run these on our design. So once we have these results, we'll be comparing the power utilization of our design versus the power utilization that is mentioned in the power and CPU utilization that's mentioned in the papers, and we'll have that to compare as well. And we are also trying to, actually the results that Sachin shared earlier their preliminary results, their result on average of just packet blocking and dropping the nodes. Dropping the packets that are originating outside of the network. We still have to integrate both of those designs into a single design to get our final router. So hopefully we'll get those done, and by the time we have to submit the final video.
We also look at some additional papers with good citation counts. And we're looking forward to read more and see if we can have more hardware benchmarks that we can compare our performance against.